good to have you involved in this. I was particularly keen to get you sort of to talk a bit about the problem solving, which really I've explained already. This is where this course came from. So you've written a paper on this. Do you want to say a bit about the problem solving course you taught at Thames?
Yeah, so I've been involved with David and others on teaching a statistics-based problem-solving course. We initially taught this at African Institute for Mathematical Sciences Centre in Cameroon. And the idea of the course was to give students an experience of solving problems, working with data, and exposing them to what statistics really is and what it means to actually be working with data and to really be solving problems with data.
One of the games that we used in that was this Millet game, which people will get to know probably.
Good.
And that really was then the starting point for the course I gave at the doctoral training school. And I guess the thing which I wanted to sort of get out of you is your experience of actually, you know, when people get exposed to sort of this sort of problem-solving approach, what have you found?
A lot of interesting things from teaching this course a few times. One of the interesting aspects of where we taught the course is that we had students with a really wide variety of backgrounds. So we had students who had done quite a lot of statistics in the past, but we also had students who came from a more mathematical or physics background. And so the types of experiences and the skills that they had were really varied. And so it was really interesting getting them working on the same problems. It meant that we designed the course in a way such that the focus was on the problems and the data and not on the tools or the methods, which meant that people could use tools and methods they were comfortable with.
I still remember the first time the course was given. I was given the mathematical problem-solving course at the same time. I think it was Tanzania we were in. And you know, the mathematical problem-solving course was the inspiration for the statistical problem-solving course, the original one. And this idea in that course that I'd sort of, you know, get people to think beyond actually trying to sort of solve something, and actually, what's a good question? I'm asking the right question. And I guess this has come back because this is at the heart of the problem-solving course. It's the heart of what we're trying to get people to think about here. It's sort of when you're wanting to do responsible AI, are you asking the right questions of the data? Can the data answer the question you're asking?
I think one of the interesting things on that aspect of the students was for them not just to try and do a lot of work with the data, but to think, what questions should they be asking? And the fact that it was okay for them to have questions, which could be actually quite specific to the field where the data had come from. And of course, them as people who are going to become experts working with data, they are not in a position to answer those. And it's okay for them to have those questions. And actually, it's better for them to be open questions where they need to get others involved to answer them, instead of just trying to answer them in their own way, which could then lead to quite poor assumptions and then misinformation being coming out of it.
Absolutely. And this is in the course, you will see this time and time again, this idea, context matters. We as data scientists, people wanting to do responsible AI, or statisticians, you know, we have to work with people who actually have the questions we're trying to answer, who understand the context, to be able to get responsible answers. If we don't work collaboratively, transdisciplinary on this, we're unlikely to get the right answers. We're going to mislead. The AI algorithms are going to get it wrong if we don't understand it.
And I think having that as being okay is a really important lesson for those people, that it's actually better to have those questions, and there are then people you can find to work with and answer them, instead of just trying to do it all yourself without all of the context of the data.
And this maybe is one of the sort of the tips for the data scientists are going to go through this course and then going to be responsible for building the AI models of the future. Don't do it alone. So you're not in isolation. Figure out who you can talk to, who understands the data you're receiving, what you're looking at, and the context within which your algorithms are going to be applied. That's what matters.
Yeah, exactly. Another kind of area that I wanted to bring out from that course was the typical nature of courses to focus on tools and methods.
Mm.
And unfortunately, if I had to say this, but if there's people on the course here with more statistics and data science kind of backgrounds, in some ways in our courses, that sometimes held those students back because they did know various methods and statistical methods and data science methods. And when they saw the data and the problem, they often tried to fit their tools into those problems and try to use what they know.
I'd phrase that differently. They tried to fit the problem into their tools.
Yes.
Which is the wrong way round. We need to use tools that are appropriate to the method.
So in some sense, their training was a little bit blinding them from what other students actually did a bit more naturally, was just to think about the data and the problems. And also, those students who had less of a statistical and data science background were actually using much simpler methods because they knew these more simpler methods like descriptive analyses and visualizations actually were often, in most cases, getting more useful information out than just trying to use things that seem like complicated tools. Yeah. And so I hope that's a bit of encouragement as well for people who don't feel they have a strong background necessarily in some of these areas. That can also be an advantage to you. You should be able to think about it coming in with a bit more of a clean slate and sort of thinking with the problem as the focus, not what you've done before, and trying to stay in your comfort zone of things that you know.
Yeah, and I think this is actually, it's something which I believe will change over time, but it is something, it's a word of warning for the experts in the field, and it's a sort of an encouragement, and it's one of the reasons that the sort of data science field has sort of blossomed in the way it has, because actually thinking about the problem, even if you don't have a wide range of expertise, you can learn what you need to do based on understanding what the problem needs, and this is sort of a really important aspect and it's true in the course that we've developed here. We've tried to focus on getting people thinking about some of the problems, some of the issues in responsible AI, rather than actually providing necessarily the tools to sort of solve particular components. We'll mention right at the end of the course some of the other courses that have been developed by the Turing Foundation, which are sort of more tools focused. And so we're not against that as a whole. We just feel there's a real gap here on sort of people actually using problem-solving approaches. Part of this course. Thanks.